Hi everyone, today we are talking about the relationships between quantities and equations and graphs. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind the video to view information again, or fast forward if you think you already got it. Be careful, make sure you don't fast forward too much that you miss out on something important. So to review what we've done so far, we've talked about how x and y are like your cause and effect, and in math we call them independent and dependent variables. So the x is always going to come first and then the y. They're in alphabetical order, so that makes that easy. The x is going to cause a change in the y. That's why the y is called the dependent variable. It's going to depend on what happens to x. We also talked about how we can create horizontal or vertical tables from an equation or rule by coming up with our own values for x and then replacing them into the equation and using order of operations to then solve for the value of y. Once we have filled out that table, we can change those values into ordered pairs with the x coming first and then the y. And then we can graph them on a coordinate plane. Remember, the x goes first, is horizontal, and then the y is vertical, going up and down. So we're just going to walk and fly to each of those points. They should create a straight line because they're following that same rule. Make sure that this is in your notes before we move on to some examples. All right, so today we're going to work more on equations, and normally we give you the equation, but this time you're going to create your own equation. So you're going to need to read carefully and look for any key clues. I also personally like to, in addition to looking for key phrases, is create a table of values. I can't stress how useful it is to create a table of values because it just organizes your thoughts easily. So we're going to do this first one together. You mow the lawn to earn your allowance. Each time you mow the lawn, you earn $12. I'm going to underline the phrase each time because that tells us that it's changing by $12 every time. Now we need to write an equation for the number of dollars, D, you earn when you mow the lawn m times. Then we need to figure out how many dollars you will earn if you mow the lawn 10 times. So first step, I need to figure out what my independent and dependent variables are. Is it my dollars that's going to change the amount of times I mow my lawn? Or is it mowing the lawn that's going to change the amount of dollars that I earn? You should have said that it's the amount of times I mow the lawn that's going to change the amount of dollars that I earn. Because the more I mow, the more dollars I earn. The amount of dollars I earn is not going to change how many lawns I mow. One causes the other to change. Okay, I can't get paid without doing the actual chore. So knowing this, I'm going to now set up a table of values. M and then D. It's kind of like my X and then my Y, or my independent and then my dependent. So in my equation later, I'm also going to have M and D. So I'm not going to have X's or Y's. I'm going to have M and D. And then remember, as before, we came up with our own values. So I'm going to come up with 1, 2, and 3. If I mow one lawn, I'm going to earn $12. If I mow 2 lawns, I'm going to earn another $12, and that's going to be $24. If I mow 3 lawns, I'm going to earn another $12, and this is going to be $36. So each time I've added 12. The key word here is each time, right? So it tells me that each time I'm going to add 12. However, be careful, each and per have also been key phrases for multiplication. And you're probably wondering, where's multiplication? All I see is adding 12. Remember, it's the independent variable that's going to change the dependent variable. So I'm really looking at the relationship between my M and my D. Is it adding 12 each time I'm changing from 1 to 12 and 2 to 24 and 3 to 36? No, that's not the case, right? So here I'm actually multiplying. 1 multiplies by 12 to get to 12. 2 multiplies by 12 to get to 24. 3 multiplies by 12 to get to 36. And you can use a calculator to double check that as well. So the multiplication is actually the relationship between my independent and dependent variable. The addition helps me build on each time, but the relationship between mowing the lawns and the dollar spent is actually multiplication. So you have to be very careful with that. So let's change this into an equation. I know every time I have to take my M number and multiply it by 12. So my M number is going to be multiplied by 12 to get my D value. Okay, and if I wanted to double check that, I could put in some numbers. 12 times 2 equals 24. Yes, that's what we got there. 12 times 3 got us to 36. Yep, we got that there. Okay, and there's no sign in between it because it means that it's invisible multiplication. 12m equals D. I could have also gone the other way and said D has to divide by 12 to get to the smaller number of m, but most people will use the multiplication because you're starting with the independent variable. People rarely go backwards from the effect back to the cause, so that should be fine. Now they're asking how many dollars would you earn if you mow the lawn 10 times? This is where your equation in your multiplication rule comes in handy, because if you were to add 12 each time to build on and get to 10, oh my gosh, that would take forever, right? You would have to add 12, add 12, add 12. But now that you have this rule that it's just the number of lawns that you mowed multiplied by 12, you don't have to do all that math. You just take 10 times 12 and you get $120. $120 if you mow the lawn 10 times. If you don't believe me, you can add up that 12 each time to get to 120, but this is like the shortcut. Multiplication is shortcut for math. Okay, so again, you could also replace the 10 for m, and you get 12 times 10 in the equation, and you get 120 as well. So that's all those questions are really telling you to do. You're coming up with the equation and you're answering a different problem that's related to the scenario. So again, making your table of values is very useful because it really just helps you see all those values next to each other. And you're just making up numbers for the x value to just have something there. Let's try one more. So for this one, I would like you to pause the video and try it on your own. All right, so for this one, they actually provided you with a table, and that's going to really help you out. And again, they just made up these numbers here. And if they have B and then P, that kind of gives you the hint that this is probably the independent and this is the dependent. But we're going to double check just to make sure. A group of 72 people traveled to the beach for a cleanup day. Some of the people brought their own supplies, such as gloves, water, and garbage bags. Supplies are provided for the rest of the people. Write an equation for the number of people for whom the supplies would be provided if B people brought their own supplies. Okay, so B is the people who brought their own supplies, and then P is the supplies that are provided. That kind of makes sense that the amount of people who brought their own supplies are going to affect the supplies that they would have to provide. The more people who bring their own supplies, the less supplies the organization is going to have to provide, okay, because they already have it covered. So this independent-dependent makes sense so far. They already made up a table for us, so we just kind of have to figure out what the rule is, okay? So we're going to go with addition, subtraction, multiplication, division. Let's start with addition. Can we add to get to the amount? What amount will we have to add to 30 to get to 42? It looks like 12. Let's see if this works each time. We have to add 12 to get to 42. And then here, do we add 12 to get to 32? No, it looks like we subtract 12 to get to 32. No. Looks like we subtract 8. So that doesn't really work. It doesn't really have an addition or subtraction rule. It definitely doesn't have a multiplication or division rule. So maybe there's something else in this problem that we're going to have to read. Let's see. There's a 72 here that we haven't really paid attention to. How is 72 maybe related to each of these pairs? Let's see. How is 30 and 42 related to 72? How is 40 and 32 related to 72? There's a total of 72 people. If 30 people bring their own supplies, we're only providing supplies for 42 people. If 40 people provide their own supplies, we're only providing supplies for 32 people. You should have figured out that it's 30 plus 42 that'll equal 72. Same thing here, 40 plus 32 equals 72. So it looks like if 30 people brought their supplies, then 72 minus that 30 means 42 people are left over we have to give supplies to. If 40 people brought their supplies, then 40 subtracted from 72 means there's 32 people left that need supplies. So these two are going to add up to equal 72, if that makes sense, because there's a total of 72 people. So you either are part of a group who brought your supplies, or you didn't bring your supplies and you need it to be provided. But together, they make up 72 people. So it looks like the equation would be B plus P, the people who brought supplies and the people we had to provide for, is always going to equal to 72. So these two numbers have to add up to 72. So 50 plus 22 would equal to 72. 60 plus 12 would equal to 72. There you go. That was a little trickier because you kind of had to understand the situation. Okay? But it's always going to follow the same rule. Okay? Let me know if you have any questions as you solve these problems, and I'll see you in class.